Hello, everybody. We are starting chapter 22 today. So that'll be the end of proportions. We're going to be doing two proportion comparisons, which is going to be the difference between two proportions. The notes are on my website, so you can go right to my website and get chapter 22 notes if you want to write on them or see anything. I would also suggest you do read the chapter so you can get really well versed with what we're doing here in class. So this chapter is comparing two proportions, and really in the real world, a lot of what's done is two comparisons because you want to see the comparison between two different things. Just so we're clear, we're going to still have assumptions and conditions for these, which are very similar to what we did for one proportion with a few caveats. Just know that what we're going to be doing is we're going to be finding the difference between two proportions. Remember that when we're doing the difference of two proportions, we're going to need to have the standard deviation difference. And when we're finding the standard deviation between two things, even though we're doing the difference, subtraction right now, we add variances. So we're going to add the variances and then take the square root of them. So the variance of the sum or difference of the two independent random quantities is the sum of the individual variances. But what we're going to be able to do is we're going to be able to use this formula for finding the standard deviation. So why don't you go ahead and write this down somewhere or just keep it in your notes. I'm pretty sure I don't have it in front of me right now, but the sheet that you guys have, your colored sheet, will have this formula there. And this is saying the standard deviation of one proportion minus the other proportion is equal to the square root of, and then these are the normal standard deviation fractions. So we are going to, oops, I don't want to do that. I want to go down. So you're going to be able to also do that with standard error if you don't have the true proportion. Okay? So you can pause if you need to, and we'll keep going. So let's figure out the standard error for this problem. Take a look at it, and then we'll follow up from there. Okay. So we're looking for the standard error between boys and girls using social media. So we're going to, I'll write it out what we're going to be doing. We're going to be taking, so the standard error, because these are not the true proportions, is just from our sample of P1 minus P2. This is P hat, is going to be equal to the standard deviation. The square root of, and now let's do our numbers. So we have 57% times 43%, which is not happening for boys, over the total number of boys. We always add plus the number of girls times the number of girls not using social media over 256. And this book is old. I'm sure that number is very, very high now for both boys and girls, but I would imagine girls are a little bit higher just based on what I know about girls in my classes. So let's take the square root, and we're trying to find the standard error of the difference in the sample proportions. So we're going to do the square root. You know what I'm going to do first, because I'm using this calculator? I'm going to do the math. So I'm going to do parenthesis 0.57 times 0.43 divided by 238 and plus parenthesis point. I don't even know if I need all these parentheses, but I'm just making sure because I want to get the work right. Parenthesis divided by 256. Parenthesis, enter. Okay, and now I'm going to do second square root, and I'm going to do, for this, I have to do the previous number, which is answer. And we get 0.0425. So the standard error is 0.0425. All right? Fine. No problem. Pretty easy, right? So now what we want to be able to do is make sure we have the assumptions and conditions before we can move forward. Many of them are similar, and you can imagine what those are going to be. And then there's one new caveat. I think it's one. So we're still looking for there to be random condition. Each group should be drawn independently and random from homogeneous populations. So if we're looking at, in this case, boys and girls, you're talking about boys and then you're talking about girls being random. We'll have some other examples coming up of different groupings, but obviously gender is usually pretty easy to see the breakdown of. 10% condition, that both of the proportions are less than 10% of the entire population. So you need to do both of them, boys and girls. And in this case, there's a third one that you have to remember, not too hard to remember because we have to think about the groups. The groups are independent of each other. The true groups we're comparing must be independent of each other. The one thing I want to point out is a big one that we use often in statistics is being able to do a comparison, for instance, before and after. I start an exercise routine. I weigh myself before, I weigh myself after. That is not what we're doing here. They have to be independent groups. The before and after we're going to do later on in a few weeks. Okay, so they have to be independent of each other, and then the sample size condition that the success failure happens. Again, what you have to do here is you have to do the sample size of each NP NQ group. So you have to, in this case, do the boys and the girls for NP and NQ. So let's take a look at this question again. Same question. Can we use these results to make inferences about all 15 to 17-year-olds? So let's go through the assumptions and conditions. So we have to talk about whether it's random. Let me see whether we have it here anywhere. Randomly selected. There it is right there. So the first thing I'm going to say is that it's random. Random sample. The independent groups. Okay. Each person is independent of each other. And then finally, we need to do the NP and Q. So, okay, so less than 10%. Less than 10% of all boys and girls. And now, let's see here. So we have 57% of 240, so 0.57 times 248. So out of the boys, there are, so boys, boys, it's 141, which is greater than 248. Therefore, the NQ would be 106, or 107, sorry, 107 divided by 248. Girls, it was 70% of 256, which is 179, which is greater than 10. Why am I writing this? It should be 10 right here. Sorry about that. 10. And then minus 256, we have 77, which is greater than 10. So what I would say is that all conditions are met. Conditions met. Use. And we're going to ultimately be using the two proportion, either Z interval or Z test, depending on what the question is. Okay? Alrighty. Fabulous. So now let's move on to the next question I have. Sorry about this. Let me go back here. So now we're going to be talking about the sampling distribution. We already know that for a large enough sample, which is what we have here, each of our proportions has an approximately normal sampling distribution. The same is true of the differences. So if we have a large enough sample, which we get when we do NP/NQ, that it's approximately normal, so we will be able to use the normal model. So what's going to happen is we're going to have the use this information to do the calculations. So, provided that the sampled values are independent, the samples are independent, and the sample sizes are large enough, the sampling distribution is modeled by a normal model, which is I just said. So, they're saying that the mean would be P1 minus P2, and we already did the standard deviation or the standard error. So here is our new formula. Take a moment to write it down. Okay, so what do we have here? Instead of having just the P, plus or minus, we have the difference between P1 minus P2, plus or minus whatever our critical value is, times the standard error, or in this case, a standard error because they're using P hats, and then it's P1 minus P2. Okay, and remember the critical value is whatever confidence level you pick. All right, you can pause if you need to. I'm moving on. So let's do an example, and then we're going to have a big example to do in one moment. So then they say, what does the confidence interval say about the difference in online behavior? So we already did our standard. We already did our standard error. Standard error, check. We already did our assumptions and conditions. Check. So now we're going to say, what does the confidence interval say? Now we're going to do a confidence interval. Okay, so let's go ahead and do that. So our confidence interval, so what I would do is I would say I'm going to use 2 proportion Z interval. And I'm going to jump right to the calculator for this. So let's go through and see what we need to do here. So I'm going to turn my calculator on. We're going to go to stat. We're going to go to tests. I'm going to go to 2 proportion Z interval for this problem. It's asking me for my X and my N. My X is going to be the number of people. So in this case, I have 57%. So I'm going to need to do 0.57 times, oops, 248. And I get a decimal, so I have to change that. Remember that we have to change it. So I'm going to do 141 and 248. And then the girls was 0.7 times 256. And I also get a decimal, so I have to change that to a whole number, 179 and 256. I'm doing it at a 95% confidence level. Doesn't say what it's going to do, but I'm going to use a 95% confidence level. I'm going to say that, and then I'm going to calculate. Okay, and here's our data. Now, because I did boys first and girls second, you can see that my numbers are negative. So you, as a intelligent statistics student, need to know that those are now going to be flip-flopped right now. So I actually didn't do girls minus boys. I did boys minus girls. It's okay. You're going to get the same exact answer. Just flip-flop. So do you see how, let me make a copy of this and show you. So do you see how our numbers are negative, right? So these numbers are negative. You can certainly have negative numbers, but in this case, I want to actually change it around because I believe the original question was something to the effect of, do more girls post online than boys, or what is the difference in the behavior? So I'm going to rewrite it myself. I'm going to write with a 95% confidence interval. The interval is 0.0473 and comma 0.2141. Now, what does this mean in context? Because I want to say that at the same time. So I'm going to say we are 95% confident that the percent of girls who use social media is between 4.73% and 2.41% higher, or no, 21.4, higher than boys. Okay. And I would probably just want to squeeze in here and may say that the true percentage or true proportion of girls who use social media is between 4.73% and 21.4% higher than boys. Okay. So let's do one together. I want you to take a moment to read this quick little blurb. I tweaked it because I didn't like how the question was done, but I found this online. Okay, so it says estimate the difference in the proportion of female students taking the Calc BC exam and female students taking the Calc AB exam using a 90% confidence interval. So let's go through what we have to do. So the first thing we have to do is we actually don't even need to find the standard error unless we were doing it by hand. And I'm not going to do it by hand. I'm going to use my calculator for that. So let's actually, before we do anything, the parameters we're looking at are going to be, I'm going to make a note. I want to tell the reader that my P1 is going to be the percent of females in BC. And I'm going to do P2 is going to be the percent of females in AB. Okay. And then I'm going to, we're doing panic right now. So we're doing assumptions and conditions. The assumptions and conditions. Let me type it out because my handwriting starts getting bad. This is not random. This is going to be the entire many high schools. I'm looking. So this is the entire list, but this is only, so it's representative of all AP Calc exams. So the 2013 is representative, so we can use that. So can be used as random. Since we have AB and BC, those people don't take the same test, so they are independent of each other. And the groups are independent of each other. The number of students, is it less than 10% of all the students who took the AP ever? No, it is less than 10% than ever. So it's less than 10%. Less than 10% of all students, of females, who have ever taken the AB or BC exam. And finally, we have to do the NP/NQ. We already have some of our numbers here, so let me tweak these. We have, sorry about this, I want to kind of like get this. Let me bring this down so I can just quickly do the numbers for you. Boop, 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 boop. Well, you know what I'm going to do? I'm going to do it up here if that's okay with you guys. So I'm going to do NP is greater than 10. So this is going to be for BC. How about that? So this is going to be the BC one is going to be first. BC. And we're going to do, the number was 84,199, which is greater than 10, obviously. And the NQ is going to be 144,796 minus 84,199, 60. That would be the boys that took it. Greater than, or males, greater than 10, that's going to be the NQ, greater than 10. And now I'm going to do the same thing for AB. The AB is going to be the number who took it were 102,598, which is greater than 10, and the number who are males that took it are going to be Where's my numbers? 211,9693 minus 102,598, which is going to be 109,095, which is greater than 10. So, okay, so sorry about that. So I wanted to do that there. So let me bring this down here. Copy. If anyone said this was easy, doing this on a computer instead of doing it on the smart board, it is not. All conditions met. Can use the 2 proportion z interval. Okay, so let's go ahead and do that. So that's all we would do there. So now I'm going to go to my calculator and I'm going to put in the data. So let's go ahead and see what the numbers were again. So our numbers, we're going to go to I'm going to go to stat, test, 2 proportion z interval. I'm going to change that to 144,796. And, oh, sorry, take that back. This should be 84,199. Delete. And then the next one should be 144,796. And then the AB students, we had 102,598. And we had total 211,693. And they want us to do it on a 90% confidence interval. So I'm going to change that to 0.9 and calculate. Okay, so this is what we got as our calculation. This is so we named the test. This is the interval. Here it is. Okay, so here's my interval. I would write it out. This is really what I would write out right here. So my interval is 0.094 to 0.099. Well, 0.010 is really what it is, right? Okay. 0.10, sorry. So what are we dealing with here? We're going to say we are 90% confident that the difference, that the true proportion of who took the BC of female students, who took the BC exam versus the AB exam is between 9.4% and 10%. Where the difference, the true proportion. Okay, good. Now I'm good now. This is what we need to write. And hey, putting little arrows all over the place, making sure we have it right is good. We're 90% confident that the difference in the true proportion of female students who took the BC exam versus the AB exam is between 9.4% and 10%. Period. Interesting. Okay, so that's it for today. So give this a review, read the book as well up to this point, and we will move forward tomorrow. Have a great weekend, everybody. Enjoy.